Coaxial cable has been around for decades. Today, the largest consumer of coax is still cable TV, followed closely by the satellite industry. But we aren't the only technologies that use coax. In fact, the automotive industry has been using it to link the antenna to the radio on cars since the 1930s. Truckers have been using it to link their CB radios to antennas since the 60s. And the military has been using it in communication devices since before World War II. So why is coaxial cable used in all these applications? Well, it's because it's designed to transport RF signals. Unlike conventional flat lead or twisted pair wire, coax contains the RF energy being transported and protects the signals within from outside interference. This is very important today since there are hundreds of thousands of RF signals being transmitted by everything from automotive radar detectors to taxis and police radios to wireless telephones. These signals can interfere with the desired RF frequencies being sent from the LNB to the receiver. Since coax has so many uses, there have been many distinct types produced over the years. These range from the older automotive antenna lead to RG59 used years ago by cable TV and antenna installers to the solid copper center conductor RG6 we use in direct TV systems today. With evolution comes change. When RG59 was first used to transport RF signals, there were only a few standard off-air signals available. Today, both cable TV operators and DirecTV are sending hundreds of frequencies down the cable. Unlike cable TV, we're taking coax even farther into the frequency spectrum than ever before, pushing the envelope in broadband delivery technology. Because of this, we need to use very high-quality cable, much higher quality than cable TV. Let's take a look at some DirecTV-approved RG6 coaxial cable. Since most coaxial cable looks alike, it's important that you know the model number you have and who manufactured it. This is listed on the box and on the cable. It should always be listed on the DirecTV approved material list if you're using it for a DirecTV installation. All DirecTV approved cable has a solid copper center conductor, at least 60% braid, and is sweep tested to 3 gigahertz. The solid copper center conductor is essential because unlike cable TV, we need to send power back up the cable to power the LNB. Since copper is a much better conductor than copper-clad steel used by most cable TV companies, it significantly reduces the voltage drop over a given length. In fact, if you use copper-clad steel, the voltage drop is almost twice that of solid copper. Using the wrong cable can underpower the LNB, resulting in it not switching properly or not working at all. Another important factor to consider when using coax is the importance of maintaining the mechanical characteristics. Even approved cable can be damaged if not attached correctly using approved attachment hardware like these cable clips. Maintaining the shape of the cable ensures the electrical characteristics will not be compromised. Staples or other attachment devices that indent the cable will change the impedance and could not only restrict some frequencies, but can actually reflect frequencies back toward the LNB, which can cause major interference. It's critical that the distance between the center conductor and the shield be consistent throughout the entire length of cable, so it maintains a matched impedance throughout the system. Another component of the cable we mentioned earlier is the shield and braid. DirecTV requires a minimum 60% braid. The braid and foil serve 3 purposes. The wire braid provides electrical ground while it also provides structural strength. The foil acts as a solid shield blocking out unwanted signals and confining wanted signals. As we said earlier, maintaining the impedance is critical. The dielectric is made of a closed-cell polystyrene and spaces the shield at a precise distance in relation to the size of the center conductor, which determines and maintains the impedance. It also insulates the center conductor from the grounded shield. The cable is also swept to 3 gigahertz. So what does that mean? It means a signal generator that creates signals from 5 megahertz to 3 gigahertz is placed on the cable, and a spectrum analyzer measures each frequency at the other end to make sure there are no defects that restrict any frequencies beyond the required specifications. Each of these components and qualities plays a significant role in making sure both the voltage and the signal travel with minimum resistance. Using approved cable and routing it without damage is critical to system performance. Bending radius is also a major factor. Sharp bends will damage the cable by changing the critical spacing between the center conductor and the shield. Never make sharp bends or force cable in a space that will crush it or change its shape.